So, what would astronomy be without studying our solar system? That's where we are. So, why not study it? Let's take a look. Studying the solar system, the formation of the solar system, is really cool. Now, you may say there's no way that we could study it since, we weren't there. Nobody knows. You can't prove it. I'm not old enough to have seen a tree grow from a seed to those huge things, around my yard, but I know the cycle of those. I can look around and I can see a seed. I can see a seedling. I can see a small tree, sapling, and I can see the progression. As we look around the universe, we can see other solar systems forming. We can look at our sun and compare them and figure out the ages and the progression. So it's kind of cool stuff. No, we didn't see it, but the evidence is overwhelming, and it's a really cool story. Okay, quick definition of the solar system is everything that orbits the sun, everything that's influenced by the sun's gravity. We personally, up until a few years ago, have only measured stuff in the solar system. In the 1970s, we launched 2 Voyager spacecraft that left the solar system just a few years ago. So they took, at something like 35 or 50,000 miles an hour, they took almost 40 years to leave the solar system. It's big. And we started measuring wind changes. And you go, wait a minute, outer space wind? Yeah, it's like a couple of atoms per cubic centimeter, where on Earth you would have billions and trillions of atoms. So it's a vacuum, but we can measure those particles and see the changes as it's flying out there. Our solar system is about 4.6 billion years old, and the planets formed less than 100 million years after that. You're going, okay, 100 million out of a billion is like is 1/10 of that. So it was fairly early. We think Jupiter formed, there's evidence that it formed about 25 million years after. So that's pretty quick. The basic steps that we see is that our solar system, and by the way, this is called the planetary nebular hypothesis. Nebular hypothesis is that we started with the diffuse cloud of hydrogen and elements and just stuff like that. And I'll tell you where those elements came from. And then through gravity, that cloud became more and more dense. Gravity pulled it closer and closer. And then eventually it becomes dense enough to start nuclear fusion at the center, which is what you call a star. And then as it spins, it flattens out exactly like a pizza dough, same physics, and this dust starts to clump together and eventually form these little planets. And then everything is happy and beautiful for 10 billion years, and then boom, the star just dies. And when the star dies, you've got this mass loss here, which forms another diffuse cloud, which will form this over and over and over again. So this is a cycle that is just really, really cool, because we think our sun is definitely a multi-generational star. A lot of stars have come before it. When a star, we're going to have a whole unit on this. In the nuclear fusion, the center of the star, it takes hydrogen and turns it into helium, and helium into lithium and beryllium and boron and carbon and everything up until iron. So everything formed in the star eventually is released and then caught up in this diffuse cloud, which then forms solar systems. So everything in the solar system came from a dead star. That's why Carl Sagan said that we are made of stardust. We're part of the solar system. That's a really neat story. So, like I said, this is called the nebular hypothesis. You want to know that. And you're going, neat story, Lanham, ha ha ha. No, we can see it. I told you, we can see places out in the universe. And here's one. This is an infrared, and a star is really bright. So they block the star, and you can see this dust. And you can see it's fairly hot right here. So this is a false color image of infrared because you can't see infrared. And there's this bright, dense, hot spot right here, which is a newly formed planet. This isn't the only one. We see plenty of these. It's pretty neat. Okay. In our solar system, and up until 10 years ago, 20 years ago, it was all we knew, but we're starting to learn a lot more because, okay, let me put it this way. Back in the day when they realized that stars were actually the same as our sun, that our sun was a star and made of the same stuff, people sat back and looked at the sky and were just like, they're little tiny suns. How cool is that? Now, when you look up at the stars, you can look up and say, ooh, look at all those solar systems. Because the vast majority of stars in our observations so far have planets. So you're looking at solar systems, not just stars. It's kind of cool. In our solar system, we have the inner or terrestrial planets. Terrestrial refers to Earth. I think it's Greek. And then we have the outer or Jovian planets. Jovian refers to Jupiter. So the inner ones are like Earth. The outer ones are like Jupiter. That's kind of a good thing to remember here. Okay. Y'all know what condensation is. It's when you have your... Well, okay, there's a little condensation here. It's styrofoam, but it's the cooling down of the moisture in the air, and it sticks, okay? As our sun emits all of these particles, all this dust, as it is spread out, they're going to kind of stick together. The atoms, the particles, the dust, is going to clump together. You've seen dust bunnies, but no, just grains of sand or, oxygen or whatever is going to clump together. The metals are going to condense. They're going to cool off and stick together close to the sun, but the lightweight things like the gases, like water, methane, ice, well, any sort of ice, not just water ice, methane ice, that's too hot close to the sun. So they get pushed a little further out, and then they start to condense. So our solar system is literally arranged by density. It's awesome to say that Mercury is a very dense planet. Venus is a little less dense. Earth is a little less dense. Mars, and so on and so on. Kind of neat. Step 2 is called accretion. When an object gets big enough, it starts to influence the area around it by gravity. Before, you might have two little atoms and they're just minding their own business, and if they happen to bump together, boom, they make a molecule, they stick. But if they just miss each other, oh well, they have to actually collide. So those two would have to collide, but something like this doesn't need to collide. It can grab. So let's say there's a molecule over here. It can get pulled in by the gravity. This is called accretion, where gravity becomes the main force. With condensation, it's intermolecular forces between molecules sticking. So once an object gets big enough to have gravity, then things change quite a bit. They get bigger much, much faster. It's literally like a snowball, except imagine rolling your snowball across your front lawn. I know I'm speaking to people in Georgia here, but imagine if it suddenly started gathering snow from further away and it didn't have to touch. You get a snowball build really, really fast. The bigger it got, the more it would pull from further away. Eventually, we have what was called the heavy bombardment period. This is a period of the solar system where there was heavy bombardment, meaning the objects started getting bigger and bigger and bigger and slamming into each other. As a matter of fact, some nice evidence of that is when an object is building like this, the intense heat keeps all of this stuff liquid, so it's like a blob of lava. And the more dense stuff, like iron, will sink to the very center. The core of planets is much more dense. It's lighter stuff that floats on top. When things get shattered, like if this got hit by something huge and just took away that outer part, you'd have the iron core left floating around and eventually make its way to Earth. So any iron that you pick up, paper clips, pencils, whatever, I don't have anything here. Yes, paper clip. That's not a paper clip. So a clip. Any of that iron in there was actually formed in an exploding star and then found its way around in the solar system, found its way to the core of what we would call a planetoid, or planetesimal, which is like a pre-planet, like a little baby planet. And then it got shattered into pieces, and that iron eventually found its way into clumps on the surface of the Earth after the Earth cooled. Otherwise, it would have sunk down to the middle. So anytime that you've got a little piece of iron, you're holding the inner part of a planet that never was. Kind of neat. Told you. The stories in astronomy, they're just better than something that you can make up. You'll see things on Facebook and Twitter and all that, like Mars is this summer Mars is closest approach in 17 years or something. That's kind of normal because it's an ellipse, but they'll hype it up and say it's going to be bigger than the moon. No, but the reality is just so much more cooler when you can hold the core of a baby planet that never made it in your hand. The history of, the reality is so much cooler than stuff that you can make up. Okay, so no, we talked about the sun. We're not going to start with the beginning. We're going to start with Earth because, hey, it's the best, right? Okay. Earth's surface, you're going, water. No. It's like the water. Think of an apple. And if you cut into it, think of how thin that is. Yeah, that's like the crust of the Earth. And the water is a thin film on top of that. So there's not a lot of water on Earth. It just happens to cover a huge surface area. Earth is dominated by tectonic plates. This is where we have the core is pretty much solid, and then we've got all these liquid parts. And this part right here, so we got solid, liquid. This is called plastic, which means it's moldable, deformed, and it moves around slowly. Think of a lava lamp sort of thing. This is actually magma, and if it comes to the surface, we call it lava. So it's the same thing. It's just whether you find it on the surface or under the surface, whether it's magma or lava. So like I said, this 30 kilometers deep is, if I put it in scale, would be as thin as an apple peel, as the outer part, the skin. Yeah, I forgot the word. And the water is just a little tiny part on top of that. So Earth is just completely dominated by these tectonic plates. And the tectonic plates are the pieces of crust that move around on top of the surface. They're literally floating. The ground that you stand on is less dense than the stuff below it, so it floats on top of it. Stone Mountain is low density rock compared to the mantle underneath. Neat. Okay, Earth's atmosphere is interesting. Not all the planets have an atmosphere. We have a fairly thick atmosphere, and being so close to the sun, the hydrogen and helium would not form an atmosphere, which is a great atmosphere. Well, not if you want to live, but, details. Our atmosphere was probably carbon dioxide. So there's a bunch of questions. Where'd all the nitrogen come from? If it's 78% nitrogen, where'd all the oxygen come from? 28%. There's less than 1% carbon dioxide left. Well, that was 4 billion years ago. A lot has happened. Fun fact, the oxygen came from I forget cyanobacteria. That's the name. They did photosynthesis. I don't teach biology, so I have to remember these words, but all that photosynthesis produced this massive amount of oxygen over billions of years. In fact, now I'm going off on a tangent. I know at one point Earth was like 30% oxygen, and there's so much oxygen that things got huge, like dragonflies as big as an SUV kind of thing. Yeah. So, still a lot of questions of really where it came from. Did it come from the rocks and work its way to the surface, which is kind of what we think it is what happened. All right, now let's go to the first planet, Mercury. No atmosphere. Now, if you start Googling, you're going to see people talk about its atmosphere. That's sometimes called the exosphere, because there might be a little tiny molecule on the surface. Okay, that dot scale is hundreds of miles big, but let's say there's a molecule and it hits sunlight hits it and it has enough energy to leave the surface and go wee. It's like the little fizz over the top of soda. You have a few atoms floating around up there. So studying that, I wouldn't call it an atmosphere, they call it an exosphere. Heavily cratered planet. By the way, let's go back to that. The heavily cratered part of the planet, it's heavily cratered because during the heavy bombardment several billion years ago, nothing smoothed it out. That is what the surface, the surface has been untouched for billions of years. On Earth, we've had water erosion, wind erosion, and mainly tectonic plates that have wiped out all those craters. Earth would have looked like this at some point, but it would have rapidly, within millions of years, swallowed up all those craters and reprocessed and everything. The moon, lots of craters, so it's an older surface. Okay. Mercury has this really cool place called the lobate scarps. The lobate scarps are these ridges along the surface. And what it is, have you ever accidentally put hot glass in cold water? It shatters. That's what happened to Mercury. It didn't get put in water, but the planet cooled down fast and it shattered. Well, where is down? It's the center of the planet. So it shattered and kind of crumpled a little bit on itself. So you see these little patterns all over the surface called lobate scarps. Okay. Now, craters can tell us about the age of a surface. If I'm looking in this picture here, I can see, like right around here, there's a crater, and then one right next to it is actually overlapping that crater somewhat. There's a big crater here, and inside it are little tiny craters. So you can get relative ages fairly nicely. There was a big one here, and then a little one there that came after the fact. And then you can get really detailed and try and figure out some of the ages. This was in one of the videos that we were looking at last week, the Caloris Basin. This is the impact that was so big, it sent shock waves around the entire planet and disturbed all of this and just like picked it up several miles high. So this happened on, if this happened on Earth, there'd be nothing left of our civilization. Some plants and animals and trees are going to survive, and maybe humans briefly, but it just totally shake up the planet. And this is an old one. This was from a fairly large object during the heavy bombardment. We don't see any evidence of anything like that happening again. We have visited Mercury with a couple of spacecraft. The latest one was Messenger about 20-ish years ago, 15 years ago. I want to say 2007. We can look it up, just going by memory. So we've measured quite a bit of it. One of the things they discovered, and you can do this by mapping out the gravity, we'll talk about that later, looking at the density, the magnetic field, and so on, is that Mercury has way more iron than it's supposed to. So it probably was a much bigger planet and got smacked by something even bigger than the Caloris Basin and just took off the outer layers. We said heavy bombardment. Now you see why they've got such creative names. Okay, other terrestrial planets, the inner planets, Venus. So this is actually last week, but you'll see it. Venus is actually dropping a little bit every morning. Actually, here's Wednesday, which I think is the day you're watching these notes, if I have it set up right. Go out before sunrise, and really, really bright in the eastern sky is Venus. And like I said, it's dropping a little bit here. So you're going to, it's going to be a little bit harder and harder to see. A year or so from now, you'll see it again. So it's not a huge deal, but it's really neat. It's the brightest object in the sky other than the sun and the moon. So, okay. Venus, yeah, this is named after the Roman goddess of love, because we, for a long time we thought it was Earth's twin, about the same size and mass, same part of the solar nebula. There are drawings of like what they thought the surface of Venus was like, and it's a jungle with clouds. They knew it was cloudy. They thought there was this massive jungle under there, and it was like cool. Nope, really, really wrong. Those thick clouds, sulfuric acid, battery acid, 900 degrees on the surface, it'll melt lead. There's so little water that Earth's dry as desert has got a lot of water. And it might be kind of an average planet. We don't know yet. So, kind of neat. There's a TV show on Amazon Prime, I think called The Expanse. I think the next season comes out this December. And I won't spoil anything, but there was some sort of life form that started, well, it didn't start from there, but there was a life form there. And I remember watching the show going, that's just dumb. And yet we have phosphine. They have measured phosphine in the atmosphere, and everything we know about phosphine is it comes from living organisms. We do not know of a process where it happens naturally without life, geological processes. So that could be our first place to find life, is on this crazy, crazy planet. It spins backwards. We think that it got hit, but more importantly, I think this is the main thing, is there's a thing called resonance. When you are on a swing and you're swinging back and forth, if you kick your feet in sync, you can make yourself swing higher. If you kick your feet out of sync, you can make yourself swing slower. And if you keep kicking after you come to a stop, you'll get going again. Venus is between Earth and Mercury, and they think that the gravity of Earth and Mercury tugged like you swinging your feet, so it slowed it down just like a swing set, and then got it ramping up backwards a little bit, which would have pulled energy from Earth and Mercury and slowed our orbits down, or our revolution down a little bit. Very poisonous atmosphere, mostly carbon dioxide, which is why it's so hot. Let me tell you about the greenhouse effect. Is pretty simple. Okay, so here's the top of the sky. I'm going to turn this into Earth, so we've got the ground here. And sunlight comes in, is completely, visible light is completely transparent to sunlight. You know that. You go outside and it's sunny. But at nighttime, the surface heats up and tries to leave as infrared light. And carbon dioxide blocks infrared light. So you have sunlight coming in, infrared can't get out, and keeps heating up the planet more and more and more. This is why we're paying so much attention to carbon dioxide on Earth. you can go back and look at sediments in the ocean and measure how much carbon dioxide was around millions of years ago. We have not had this amount of carbon dioxide in our atmosphere for millions of years. I think 25 million years. And when we graph this, when we take a look at it, I'm going to graph. So this is time. Typically, the carbon dioxide levels would have changed a little bit through the years. So you'll hear people say the global warming is not real. It's just another cycle of Earth. Well, they're right, but it doesn't change that rapidly. This is called the hockey stick model. I made it a little, actually, it leans back a little to the left, so it goes back in time. But our rate of change is like 10,000 times faster than carbon dioxide has ever changed on Earth. So this is why we're talking about major problems. This is why we're in the 6th extinction event. But on Venus, this was completely runaway. Just the surface stays at like 900 degrees Fahrenheit now. When I go out and cook steaks on the grill, I like to get up to about 600. I would have like perfect steak and like what do they call the steak that's not even cooked in the middle? Blue. So if you like that, but you'd have to eat it fast because it's going to keep cooking while you eat it. Well, you're dead, but you know. Okay, more fun stuff. You can see the surface by radar. In fact, the very first picture taken was kind of funny. The Soviet Union was the first one to put a lander on Venus, and they set up this instrument to measure organic material, to measure the jungles, right? They were pretty convinced that wasn't there, but by that time. But they set up an instrument to measure organic material to go find life. And immediately the sensor went off. There was organic stuff there, which was like, wow, there's life on Venus. How exciting. How come the camera doesn't work? The lens cap, plastic, organic material, melted to the camera, and that's what they measured. So later they came back. I think it was also the Soviet Union that landed and got the first pictures from the surface. And the lander doesn't even last an hour on the surface. It's just so brutal. I don't even know how long the camera lasted. But we can get very detailed measurements from Earth using radar. Okay. It didn't last long. I've said that. Oh, yeah, there's so much atmosphere. If you've ever... I remember, I don't know which one, but an old World War II movie where they've got the bunk beds in a submarine. And they've got a new guy on the sub, and the old guys totally freak him out by taking a string and they tie it from one bunk bed to the other. And as the ship goes deep underwater, the string does this because the ship is being crushed by the water. It gets smaller and smaller. They had a lot of fun freaking out the new guy. But it would be way more extreme on Venus. There's so much atmosphere that it would crush you. You wouldn't survive just that. If the surface is smooth, how old is the surface? Answer: the heavy bombardment happened all over the solar system. In other words, the surface should be covered in craters. The fact that it's smooth means it's relatively new. So some process changed the surface of Venus. That process is volcanoes. It is the dominant feature of Venus. Tens of thousands, if not hundreds of thousands of volcanoes. And these are what are called shield volcanoes. Let me show you the difference here. A cinder cone volcano is going to basically shoot stuff in the air, and it's quick and dirty and doesn't actually last long. But a shield volcano slowly pumps stuff to the surface where it just kind of smooths out over a long period of time. So you get a huge, broad volcano. And that's an indication that it's been going on for a really, really, really long time. Okay. And the hot spots. This is so magma reservoir down here. There's hot spots deep under the surface. So that's another reason why it just sits there for a long time. No plate tectonics. The island of Hawaii is actually a chain of islands, not drawn to scale. And what happens is the crust of Earth will go over a hot spot in the magma and will slowly produce this chain of volcanoes as the Earth moves above this, across the hot spot. And that's why we get a chain of volcanoes like on Hawaii. The big island of Hawaii is a shield volcano. It is very broad. It's been going for a long time. Nothing like on Venus, though, because the plates move fairly slow. Okay. Mars. This has got to be the coolest planet. After Galileo, he didn't have this good of a view. This was our view of Mars. And you can actually see some features here. There's this white spot on top. There's dark areas, and they could see colors changing. At the time, they were like, wow, this has got to be a polar ice cap, just like Earth. And if the colors are changing, that means the leaves are changing. It's spring and summer and fall and winter, and yay, it's all exciting. There was a guy by the name of, this Italian guy, and he mapped out what he saw, and we look at it now, and it doesn't really match what we know. So telescopes were just starting to do this. This region right here, he probably had correct. I'll tell you what that is. Oh, wait, no, it's right here. Tharsis, which is, I think, ancient Greek for the westernmost part of the world, the edge of the world, the wild. Tharsis region, I'll tell you about that. That's got some exciting stuff. The fact that, I don't know. The fact that he noticed it was dark here, light at the top, not so much. The interesting thing is these channels, as he called them, are canali in Italian, which got mistranslated in English newspapers, bringing about this wild idea that there were canals on Mars. This was the time when the Panama Canal was built. It was the greatest engineering achievement of all time. And yet, a couple hundred miles or so? These would have been thousands of miles visible from another planet. So that mistranslation literally led to the concept, the idea that there were aliens way more advanced than on Earth living on Mars. And what they hypothesized, is that the ice cap up here was where all the water is. It was a desert in the center, which is actually about right. And the advanced civilization built canals thousands of miles long to bring water down to their cities. Okay? That one mistranslation led to all of our science fiction stories about Mars. War of the Worlds, here's Mars Attacks, My Favorite Martian, Marvin Martian. I don't know, but it looked cool. I found that on the internet. And this one, of course, is a real image. If you look up Face of Mars, yeah, it's a real thing. This was taken in the 1960s, I believe, and it was like the only picture they had of the area. And it wasn't until the 90s, I believe, that they went back and got more measurements, and they took a picture of that hill again. And just like the scientists said, it didn't look like that. It was just a trick of shadows. And the hill doesn't look anything like that. But they did get a 3D image of it. So if you build this out of clay and then take a flashlight and shine it around, you're going to hit a spot that's just right that makes a little face like that. So, kind of cool. Okay. Last summer, I went on vacation out there. This is one of the small telescopes, And we got to look at that and look at a star in the daytime because it's a big enough telescope. The Lowell Observatory is up on a mountain outside of Flagstaff, Arizona. The road going up was kind of cool because I heard stories about how they used donkeys and mules and horses to bring all this scientific equipment to the top of a mountain, this really remote place, and build it. So here's the main telescope here that Lowell built. He was an eccentric millionaire like Bruce Wayne that wanted to build things. And in these pictures, you can't see it here, but they actually have car tires from that time period that help the dome rotate. This little chair right here is weighted for Lowell. Percival Lowell was his name. And he used this telescope to try to look at those canals on Mars. And he made detailed maps of these and was one of the main people, the driving force of Martians. And wow, if they're so advanced, what if they invade us? And there's our whole history of it. So he thought he was legit. It turns out, if you've ever looked in binoculars or a telescope or microscope, you see weird lines. It's light reflecting off the back of your eyeball. You're seeing the veins on the back of your eyeball. So he probably spent years mapping the back of his eyeball. And I guess not too many people were willing to tell him, I don't see that. But anyway, this is outside the telescope here. This is all at Lowell. And I threw this picture, and I'll come back to this another time. But this is, that building right there is where Pluto was discovered. So I had to take a nerdy picture in front of that. Mars, mostly carbon dioxide. So you're going, it's hot, right? No, it's really, 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 really thin. If you stepped out, you would not have enough oxygen to breathe. There's a little oxygen, but you suffocate. There's just, it's thinner than the atmosphere on top of Mount Everest by far. A hot day on Mars would be about 50, 60 degrees Fahrenheit. So cold day, though, would be cold enough for carbon dioxide to solidify. So we're talking 100 below or more. Very thin. Okay, the geology of Mars, we're learning about it, is, well, it's like Georgia. The red clay is due to iron or rust in the soil. So that's Mars's lots and lots of iron on the surface. Remember, that came from the core of old planets that never made it. We definitely knew that there was water on Mars. That's new. Within the last 10, 15 years, we've got just amazingly strong evidence of it now. The two things that we should remember are erosion and hematite. Hematite is a mineral. I'll show you that. Olympus Mons is the largest volcano in the solar system. If Mount Everest is 6 miles high, I believe that Olympus Mons, or Mount Olympus, if you will, is something like 50 miles high. Maybe it's 20. I always forget. But it's big. It's just massive. And it hasn't sunk into the crust, which it should have. If it was on Earth, it would be gone. It would sink, which tells you that Mars has a very, very thick crust. Okay. In late 90s, early 2000s, I think it was 2000s, we had the Mars orbiter, and it used a laser altimeter. And that just means that it bounced a laser off the surface back up to the satellite, and it measured the altitude, the distance. So all of this, the false color images here, are altitude. And you can clearly see there's some weird ones right here. This is Mount Olympus, okay? I said it was big. You can't see Earth volcanoes from space. Well, no, you can. Okay, my bad. But nothing like this. This is huge. And then these three here, this is called the Tharsis Plateau. I was telling you about that. So you can see it's all the same color, and it's really high up, plateau. And Mount Olympus, Olympus Mons, is a little bit off there to the west, and we have this big gash right here. This gash was named after the spacecraft that first got there, Mariner, the Mariner spacecraft. So this is called Valles Marineris, Valles for valley, and it's just like the Grand Canyon, except it's 2,500 miles long. So this right here, this little region here, I'll just draw it, is about the size of the United States. That's a good map. I'm not an art teacher. The thing is, every physics teacher will tell you, I can't draw. Well, I really, really can't. Okay, so what about this? There's this whole region that's actually lower. That, we believe, was an ocean about the size of the Atlantic Ocean. So, pretty cool stuff. Big area of possible lake here, and it's a circle. Yeah, formed by a crater, probably filled in with water. And, well, not probably. Let's look at some of this stuff. Here is the Tharsis region, or the Tharsis Bulge, closer up. And I'm going to have to come down to here and show you that this is actually an ancient shoreline. So let me switch apps here. You can see river outlets. So right here is an ancient riverbed. Oops. And we've got better images of this, but you can see this all over the place. And then it drops off right here. So when we compare the features seen on the satellite images, they're the exact same things that we see on Earth along dry lake beds, river beds, the ocean. There clearly was an ocean there. So Mars used to be a lot wetter and warmer than it is. So the conditions for life were absolutely perfect. Okay. Now this is something that you can do if you want. This is Google Earth. And you do, let's see, View, Explore, Mars. And this is Google Earth, but Mars. And they take a whole bunch of satellite images and they try to, make it interactive. So if I swing things around, I kind of know my way around Mars. I would get lost there, but this image, it's a little harder to see. Okay, there. So this is the obvious one right here, is you have Olympus Mons and these three volcanoes. And as a matter of fact, when Marinus first got to Mars, there was a massive dust storm on Mars, the biggest they'd ever seen. And the poor orbiter went around for, I think, a few weeks, seeing absolutely nothing. And then all of a sudden, these four objects started to show up because they're so tall as the dust settled. So those were some of the first things they saw. Okay, I told you this is a big, big volcano. Now, if you've ever seen a picture of a volcano, been on one of the things that you think of is the really steep sides, right? This volcano is so big, if you were on the side, if you were, along the slope, you would not realize that you're on the side of a mountain. It's that big. Let's go check out the crater here. Okay, let me come here, and I'm going to spin it around, and we're going to look up. So now that we're getting this little 3D image kind of thing, oops, come back. And now it's looking like a crater here. So we can kind of pretend to be in this crater, and let's look up a little bit. And you can see this nice defined rim, and you go, hey, there's a highway. No, those are different images from different satellites. So this is one of the highest resolution ones. And you can see that sand came down the slopes. And they've noticed that these slopes will change colors, not up here at the top, but in other places. And there was a student at Georgia Tech a few years ago that started using spectrometer data, spectroscopy, that's what I'm trying to say. And he analyzed those dark spots carefully, and he determined that, yeah, it's actually water. So this was the first evidence or first proof that, we're seeing water. We saw these features that had to be formed by water, but were they really? And yeah, now we know that they were. So he found, think about that. You're a college student discovering water on Mars. How cool is that? Now, I told you that if you're on the slope, you wouldn't even realize that you're on a mountain slope. This looks like flat plains, but as I come out of it, there's the volcano, and that's pretty cool. So let me come over here. Here is Valles Marineris. It's a little hard to see on this image, but it extends from the left to the right, and this is about 2,500 miles long. And I told you that it's a lot like the Grand Canyon. Check this out. Look at that. That is formed by water. Was formed by water. So what we're seeing here is like if I'm over California right now and on the horizon is New York. So completely dwarfs the Grand Canyon. But oh my gosh. How cool is this? We've got that much data that we can play around and do things like this. So this is Google Earth, but you go into the view for Mars. I took a class from Mike Brown, this astronomer at Caltech. We'll learn about him. He's pretty significant. Called Science of the Solar System, and we spent weeks using this data. It's really neat. Okay. Give me a minute. Let me go find where I was. Okay, so some of the things that we've sent to Mars, I'm pretty sure that this is Mariner, and then this was one of the Viking spacecraft that first set foot on Mars, and it didn't go anywhere. It's just got legs. It did have an experiment where it scooped up soil, heated it up to see what stuff was there, kind of look for life, basically just see what elements were there. And they detected organic material. And we're like, cool, we just discovered life on Mars. They discovered it by burning it. Our first contact with Martian life was to destroy it. Well, we don't know if it was alive. They dismissed the data quite a while later, saying, no, it's tempting, but it's not. It's not proof of life. Since then, mathematicians, statisticians have been studying that data for decades, and some of them have come up with a conclusion saying, actually, that may have been bacteria. There's some evidence there, but I think most of the scientists dismiss that. And then we've got, I can't remember the name of this one, Phoenix, I think. This was the one on the movie The Martian that he went and, spoilers. Then we had these twin rovers. Oh, I forgot to tell you about that. I said that we know there's water on Earth because of the surface features, but also hematite. Okay, hematite is a mineral, and they discovered hematite from orbit using this, and there it is right here. They've discovered a mineral called hematite. On Earth, hematite forms in liquid water, which was like, whoa! This is before the Georgia Tech kid. This was an indication that there was actually life there. So they sent two rovers, and they changed the direction or the location of one of them. These were Spirit and Opportunity, and I don't remember which one is which, but one of them went to that site to look for the hematite. And what it found was a cliff about 20 meters high, I think. And in the cliff, you've got all these layers. So you've got millions of years of data from Mars. And as it started looking, it noticed these little tiny round spheres through all of it. And the pictures that NASA took, they used false color to point out things. Well, they made those little spheres blue, so they started being known as the Martian blueberries. Those were the hematite particles. They're like smaller than a BB. They're about a millimeter in size. And that is formed in liquid water as those sediments formed. So that was our first evidence that, yes, water did exist. And now we know it does exist. So is Curiosity. Those two, by the way, were supposed to last something like 9 months. And one of them got stuck in a hill, and they couldn't put it on a hill with the solar panels facing south to make it through the winter. You've seen Wall-E. Had to charge its batteries. It never survived. It didn't survive. And then the other one, but that one lasted like almost 10 years. I think the other one lasted 13 years or so. It wasn't until last year, I believe, that they finally said, yeah, it's dead. We're never going to contact it again. And then Curiosity here, this is the size of an SUV. So think of an Escalade driving around on Mars. This back end, though, is a nuclear reactor. And up top here, it's got multiple cameras, and it's even got lasers. So, yes, there are alien robots roaming Mars that are nuclear powered, shooting lasers. We just need sharks. And what it did is it would use its laser to drill into a hole and then use spectroscopy to find out what's under there. Because so far we've only looked at the surface. We've got, I think we sent one that might be there that's meant to dig holes several feet into the soil, but I think it got stuck or something. I forget the name of it. We'll have to look that up. So Mars is definitely a cool place to check out. There's definitely water there. Okay. If you have red-blue 3D glasses, which I've got some that a lady at NASA sent me, but with the pandemic and all of that stuff, I'm sorry, but we're just not going to be able to see them. But if you have some, get those out and skim through here. You can pause it on your own. But when they take 3D images of the surface, then the people on the ground, the scientists, can put on 3D glasses and check it out and say, oh, let's go over there. I mean, it gives you a much better image. It's more like being there. So if I remember right, this is a really cool one with 3D glasses. But if you have those, these are, let me go back. Those are the blueberries. Those are the hematite. Get the lights to turn back on. Those are the hematite blueberries that they found. Okay. And then this is actually still going around on the surface. And we have another rover that is on its way right now. And it's the first one to look directly for life. Kind of neat. Okay. Curiosity took these pictures. So this is a dry stream bed that is the people who study streams, stream scientists, I don't know what they're called, type of geologists, looked at this and they said, based on the distribution of the particles and the size and how worn down they are, how smooth they are, they determined that this creek flowed for at least 10,000 years. So water was not an anomaly on the surface. And this is my favorite from Curiosity. It's got multiple cameras on board and did a little selfie here. Best selfie of all time. This site, check this out on your smartphone. It's pretty cool. And y'all have a good day.